All right, in order to determine the specific edges of this that end up overlapping from or connecting one surface to the next, I need to first identify just where the triangles are at all, make sure my math is correct on it, so I want to visualize it. And here's a very simple script that will show that visualization. It has a reference to a mesh filter that's actually based on the parent object, which has a mesh filter in it. But over here, we're then going to go into the script so we can see how we're outlining the individual triangles for this object. All right, so in this, there's our reference to the mesh filter. It's pretty straightforward. Then the only other function that we have inside of here is onDrawGizmos selected. So every time that it wants to draw the gizmos in the IDE, this command will be called. And so then we set our gizmo color, which is blue in this case, so we see blue lines over it. Then we're also getting a list of all the vertices and the triangles, an array of vertices and an array of triangles. Then we're going to be creating a draw function inside of here that basically tells the gizmos to draw a line from the first vector passed in here to the second vector passed into here. Okay, and then the last part is that we iterate through each one of the triangles on here and draw out connection points to the three different vertices. So we connect from 0 to 1, from 1 to 2, and from 2 back to 0 again. All right, but there's a little bit more that's going on here. First off, when we are gathering the shared mesh, or the mesh filter vertices and triangles, we are using the shared mesh in specific. This is important. If I go into the code and I click on this, which right now this takes me to this outline object here, and when I click on this, here's the actual object. The mesh filter relates to an object that is stored inside of the game, inside of this main ship 001, one of many parts of it. Now, that is referencing the specific mesh from within it. If I were to change this out to mesh, just the act of getting the mesh tells the mesh filter that, oh, we're probably going to be doing something with it. We need to hold on to that information. The thing is that this mesh filter probably doesn't even know the information to a lot of it. I'm not even certain about how it works under the scenes. I mean, the collider is going to need to know it. So obviously it does need to be passed off to other systems, but probably not in the C# side as much. So when we're holding on to this, this might be our only real reference to it inside of C#. So if we grab the mesh. So we want to get the shared mesh. The shared mesh is this original instance of it. We tell it, give us the original copy, just what that one is, and you don't need to reproduce a new one. So when I go back to this, if I have this single mesh reference into there, that is now ship LOD0 instance. When I click on it, it goes to this, but it isn't represented by anything here. So if I go back to this object and I click on that reference, oh, not that one, but this one, it doesn't highlight anything in here. So I need that to go back to shared mesh. There's going to be two more points to this. Okay, so shared mesh, did I save it? All right. Now that doesn't fix this. That instance is still storing its own list of every single vertice and every single triangle within that mesh inside of this game object that is serialized to the scene, meaning all of that data has to be reloaded from the scene and you lose all your reference and source updates. So if you ever change out the source object, it doesn't matter. Your mesh is already instanced. It's this specific version of it. Okay, now that instance still doesn't go to where I need it, so I actually have to go back down to here, find ship LOD0, and drag in this new replacement. Now it's storing it. It does keep the information because that script is set to use the shared mesh instead of the mesh. All right, the next thing is that on the draw gizmos, we're not just drawing the positions, we're drawing them with transform point. So your model comes in, it gets imported, and all of those positions are within the model space. But when they got imported, if I take a look back at this, we can see that it is actually, this has been rotated 90 degrees. It's also been scaled to 10 times the size that it was generated in the original mesh. So that means that when I actually take one of these points, it has to be rotated 90 degrees around the center of the object, or center point of the object, not necessarily the center of the object, and then, or the anchor point. And then it has to be scaled 10 times out. So if it was 1, it becomes 10. Transform point is what does that for you. It does it based on the scale of the transform you're in. Now, there's a potential bug that could happen here because here is the transform for this particular mesh filter. And where I'm drawing the lines is a separate transform. So I'm technically using this transform. However, this transform doesn't modify anything. So it's 0 for position, 0 for rotation, 1 for scales, which means that it actually is whatever the parent is. And it's technically a combination of what all the parents are. So if the parent above it scaled by 10, and then that one scaled by, the parent scaled by 10, and then this one didn't scale at all, it would actually be a scale of 100 from whatever this one is, or whatever the real world is. Okay, so that gives us that one. The last thing are the triangles themselves. So I got those ones. The last one is the triangles themselves. When we're drawing these, the triangles are if I take a look at this, the triangles are an array of integers. So it's an array of integers, and that returns the index to which vertice to use for that triangle. Now, there are some interesting side effects that you will find. Some models might have them, some models might not. Where when a triangle is working with this, the vertices might not be unique. So you might have a single vertice repeated in multiple points in the vertice array. So the vertice array is actually vector 3s. Those are our 3D positions in space. The triangles tell us which ones to look at. So originally, I had actually tried to go through the vertices, triangle by edge by edge, to get the triangles, and realized I needed to use triangles to get that. And then I also ran into issues where I was trying to use the indexes to identify when things were similar. But I can't, because sometimes the indexes are only to one instance of something, where that same vector 3, that same vertice might be used under a different index as well. Okay, so anyway, that's how I draw the lines. And when I ran the code and just let it run inside of this and have the object selected, we get all the blue triangles exactly where I'm expecting them.